This video will cover Year 10 Pythagoras and Trigonometry. This is the fundamentals test preview, which is C-level questions. So if you're following along with the test preview, we've got some time tags down the bottom, so you can just skip the question numbers that you need help with. And if you're just following along, you can use the descriptions on the time tags to help you with the sort of questions that you're looking for help with. In question 1a, we're being asked to find out x using Pythagoras' theorem. Now x is the hypotenuse, it's opposite the right angle, it's this one here, and it's also the longest side of the shape. So we're going to use the formula c squared equals a squared plus b squared. It's important to understand that the hypotenuse is always c, and that either other side can be a or b, they can be interchanged. And all we do now is we just substitute the values in. So if c is now x squared, and we'll sub in 5 squared plus 12 squared. Now x squared will be 25 plus 144. So x squared is 169. And this is really just the balance method now. What we're doing is we are square rooting both sides. And what will happen is the square root will eliminate that squared there. So in our next line we'll have x, and that will be 13. Remember that this square root symbol asks what number multiplied by itself makes 169 in this case. And just quickly before we finish, we must not forget to put our units, which are centimetres. Question 1b, we're being asked to find x, the hypotenuse. Remember that the hypotenuse is always the longest side, the side opposite the right angle. So we're going to use the same formula we did in 1a, which is c squared equals a squared plus b squared. Remember that the hypotenuse is always represented by c, and a and b can be put in any order that you like. And what we'll do now is we will just substitute the values in. So c becomes an x, a might become the 1, and, a's become the 1.4 in this case, as per the drawing. And b has become the 1 squared. So now we've got x squared equals 1.4 squared, which is 1.96, and 1 squared, which is 1. So x squared is 2.96. And at this stage, we're switching to the balance method. We have to get rid of this squared. The opposite square is to square root. So we're going to square root both sides, which leaves us with x over this side and 1.72 meters on the right. Question 1c, we are being asked to use Pythagoras to find m. This time m is not the hypotenuse. This time 25 is the hypotenuse, and these guys might be a and b. Now, for those guys who've got a keen eye, they'll see that this is actually a Pythagorean triad. So this m is actually going to be 20 centimeters. But if you can't see that, you should use Pythagoras to solve this one. And this time we're going to use the rearranged formula. So instead of using c squared equals a squared plus b squared, we're going to use a squared equals c squared minus b squared. So we've used transposition to get a new formula. And now we're subbing in the values that we're looking for. So a becomes an m, and then c becomes 25, b becomes 15, and we start to solve. We've still got m squared, we've got 25 squared, which is 625, and we've got 15 squared, which is 225. So now we've got m squared, and that is 400. And we switch over to the balance method, because we know that the opposite to squared is to square root both sides. And so we'll be left with m equals 20. Not forgetting our units, which are centimetres, sorry. Question 1D, we need to use Pythagoras theorem to solve for the for x, and again x is not the hypotenuse this time, 6 is. So give them all the value, and we're going to use the transposed formula, the rearranged one. So because we're not looking for the hypotenuse, we'll make a the subject. So we're using a squared equals c squared minus b squared, and we'll sub our values in. A has become an x. C has become 6, and B has become 4.4. So we've got x squared equals 36 minus 4.4 squared, which is 19.36, which leaves us with x on the left and 16.64 on the right. So we've got x squared. And now we go for the balance method. So we're trying to get rid of that squared by square rooting both sides. So x will be 4.08 millimeters. Don't forget your units. Question 2, we've got a worded question. The first part of it is that we need to mark measurements on the triangle below. If we don't do that, we'll miss out on those marks. So it has a base of 6.4 centimeters, and it has a height of 10 centimeters, and it's asking us to find the length of the hypotenuse. Okay, I'm going to use x, but you can use c if you'd prefer to use c. So we are going to use the formula c squared equals a squared plus b squared, because we're finding the hypotenuse. So we'll substitute in. C will become an x. A might be 6.4, doesn't matter. And B might be 10. And so we're left with x squared, 6.4 squared, which is 40.96, and 10 squared, which is 100. So x squared is now 140.96. We'll switch to the balance method. We square root both sides to get rid of that squared. And that leaves us with x equals 11.87 centimeters. Question 3 is asking us to find the hypotenuse. So we know we're looking for this side, the longest side, and it says that it has shorter sides of lengths 7 centimeters and 3 centimeters. So because we're looking for the longest side, the hypotenuse, we're going to use c squared equals a squared plus b squared. I've chosen to use an x for the hypotenuse, but you can keep it as c or a h, whatever letter you like. I'm going to substitute in now, so c becomes an x, a becomes a 3 or 7, and b becomes the opposite, so 7, which means we've got x squared, we've got 9, and we've got 49. So now x squared equals 9 plus 49, which is 58. I'm going to switch over to the balance method and square root both sides to get rid of that squared. And so now I've got x on the left and the square root of 58, which is 7.62 centimeters, not forgetting our units. Question 4 is exploring these trigonometric ratios. So to answer these, you will need a calculator, and you just put cos 59 into your calculator, and it will spit out an answer that is lots and lots of decimal places. And then in the second line, you should round these, maybe down to 2 decimal places, okay? So remembering that when you're doing decimal places and rounding, look at this number 1 here, and if this number here is 5 or greater, the 1 becomes a 2. There's no need for units on these because they're ratios. So in the second one, if we put that into our calculator, we'll do 10, 33.1 equals, and we'll get 0.651892, and we'll be bringing this down to 2 decimal places as well, okay? So here when we write this one out, we've got 0.65, but the 5 doesn't become a 6 because this little number here, the 1, is less than 5, okay? And in the final one, if you haven't seen this before, this is called degrees and minutes, and you've got a special button on your calculator for this one. If you're running a Casio, it'll look like a circle, a comma, and then 2 commas. And if you are running an abacus, you'll see a D and S button on your calculator. So when you guys enter these ones in, you're going to need to go sine 43 and push the degrees button, then type your 22 minutes in and push the button again and hit equals, and you'll get the answer 0.686665, and then we'll do the same thing. We'll just round this one down to 2. I can see that when I write the answer here, I've got 0.6, and then the 8 becomes a 9 because this number is 5 or more. In question 5, we're looking for angles rather than ratios. So we need to start by rearranging these equations. So A, if we look at this one as a balance method, what we're actually doing here is we're dividing by sign on both sides. But we don't write it like that. What we write it like is inverse sine, which means the same thing, 0.7. And we put that into our calculator, which will give us 44.427004. And we need to round this one, same as we did in the question above, to 2 decimal places. And so this one will become 44.4, and the 2 becomes a 3 because this number here is 5 or greater. And we're going to remember degrees this time because there are units for these questions. So similarly in the second one, A will become cosine to the -1 or cos to the -1, 0.85. which we'll put in our calculator, and to do that you push shift cos 0.85 equals, which is 31.78833062. We're going to round that one down to 2 decimal places, so we'll have 31.7, and it will become a 9 because this is 5 or greater, and we're going to remember to put in our units, which are degrees. Question 6 would like us to use trigonometry. So whenever you hit a trigonometry question, it's always a good idea to start off by making yourself a note. So, Toa, that way you can remember the rules. So it's sine equals opposite on hypotenuse, cos equals adjacent on hypotenuse, and tan equals opposite over adjacent. And so what I like to do is I then like to go through and label my sides so that I don't get confused. So knowing this is the right angle, this one would be the hypotenuse. And then relative to this angle here, 4 will be the adjacent, because adjacent means beside or next to, and the opposite is the one that is clear of it and isn't connected to that angle in any direct way. And so now what I'm going to do is I'm going to decide which rule I'd like to use. And the way that I do that is I have a look, and I've got an adjacent and I've got a unknown hypotenuse. They're the two that I'm hunting. So I have a look up here and I'm deciding that I'd like to use the cos rule this time. So I come in and I say cos 44 equals the adjacent over the hypotenuse. So 4 over v, because v is the hypotenuse. Now, when you come to do this section of it, you can use transposition to first move v up here, and then in the second move cos 44 back down. But usually what we do is we just remember that we're allowed to switch these two so that they swap positions. And so I've got v equals 4 over cos 44, which I then put in my calculator and find the answer to be v equals 5.56 meters. And just as a double quick check, I have a look and think 5.56 meters, the hypotenuse is definitely going to be longer than the short sides, so that would make that 5.56 and this 4, so yes, I've probably got that answer right. Question 6b, we're using trigonometry again, so we'll go and have a bit of a look at this triangle this time in B, and I mark in the hypotenuse so I don't get confused. So this side, the number 2 will be the hypotenuse this side, the one that's opposite the right angle, the longest side. And then I'll mark the other sides in looking at it relative to the angle that's known. So if this side here is next to it, it's the adjacent, and the x will be the opposite because it's completely opposite side of the triangle and it isn't connected to the angle in any direct way. So what I'll do next is I'll have a look at what I've got. I've got I've got an opposite this time, and I've got a hypotenuse. And so now I'm going to go looking for the rule that's going to help me with this. And this time it's going to be the sine rule because it's got the opposite and it's got the hypotenuse. So this time we're going to start by writing out sine 6 equals the opposite, which is x, over the hypotenuse. And unlike in question 6a, this time we can use the balance method to multiply by 2. This says divide, so I'm going to do times. That gets rid of it. But anything I do to one side, I've got to do to the other. So now my revised rule is 2 times sine 6 equals x, which I put into my calculator. And that means that 0.21 is equal to x. And so just to neatly write that out, I'll say, okay, that means that the unknown side x is 0.21 meters. And I have a quick think about that, and I think, yeah, this side has to be smaller than the hypotenuse, so I might be right. And if I'm double guessing myself, because it's a very small number, this one, for those who can imagine triangles, imagine that this 6 degrees is only a very small angle and this triangle is not the scale. It probably looks a lot more like this, and so that it makes sense that if this side's 2, this side is going to be quite a lot smaller. So we've got this one right. Question 7, we're using trigonometry again, but this time we're trying to find angles instead of sides. So we're going to use the inverse rules. We're going to set this up in a very similar way. We're going to start by writing SOHCAHTOA to help us with our rules. And I'm first of all going to start by naming these triangles. So I know that this side is the hypotenuse, and then using this as my reference, this one will be the opposite because it's not connected in any way. This one will be the adjacent, but I won't need that one for this set of questions. So I can see here that the sine rule is going to be the best because I've got the opposite and the hypotenuse that I need to work with. So I'm going to start by using sine theta equals the opposite over the hypotenuse. So sine theta will be 2.4 divided by 3.5. And I don't want to find what sine theta is, I want to find what theta is. So it's really the balance method. What I'm doing is I'm dividing by sine on both sides. And the way that we now write this is theta equals sine to the negative 1, or inverse sine, times 2.4 over 3.5, which I then put in my calculator, and theta will be 43.29 degrees, not forgetting your units. Question 7b, we're using trigonometry again to find an angle rather than a side, so I'm going to name up my sides. So using this as my reference angle, this one's going to be the hypotenuse, which I won't be using for this question, but that will make, relative to this angle, 7 the adjacent because it's beside it, and 11 the opposite because it's clear of it. And now I'm going hunting to see what rule I need. I've got an opposite and an adjacent, so this time I'm going to use the tan rule. And that will match my opposite and my adjacent. So I'm going to come in and start with tan theta equals opposite over adjacent, and that makes tan theta equal 11, which is the opposite over the adjacent of 7. I don't want tan theta, I want just theta, so I'll divide both sides by tan, and I'll find that theta equals tan to the minus 1, or inverse tan, 11 over 7, which I'll then put in my calculator, and theta will be 57.53 degrees.